To solve inequalities, we want to go through the same steps that we did with equations. The first thing is that our goal is to isolate the variable. So we still want to get the variable, the letter, on one side of the inequality symbol and all of the numbers, the other stuff, on the other side, and that gives us our solution. We want to do that by undoing the steps that are there using inverse operations. We want to sort of do the opposite of what we see, and at the same time keeping the inequality balanced. Whatever you do to one side of the inequality, you must do the exact same thing to the other side. So those steps are all the same as what we've been practicing with in solving equations. The only thing that's new for inequalities is that when we're in a multiplication or division step and dividing by a negative number, the inequality symbol gets flipped around and faces the other direction. So this is why it's so important to keep things organized and to show your steps like we've been stressing in class. So when we look here at A, our directions ask us to solve and graph the following. So we see that it is multiplication in the problem. We undo that using division. So we're going to divide both sides by 2, and we're left with x is less than 5. Because it asks us to solve and graph the following, we're going to use this line that's here, and we want to graph our solution, x is less than 5, by creating a number line showing where 5 is. And now, because it's not equal to, it's not x is less than or equal to 5, we can't include this value. But we do want all of the things that are smaller or less than 5 all the way up to, but not including 5. For part B, we have nearly the same inequality, only this time it says negative 2x is less than or equal to 10. So we have multiplication in the problem. To undo that, we divide by negative 2 on both sides. And then we're left with x, and here on the other side we have negative 5. But like we said, when we multiply or divide by a negative value like we did here, we divided by negative 2. Then the inequality needs to face the other direction. So we're going to have here that x is greater than or equal to negative 5. So when we put that on our number line, our solution here with negative 5, we want to include that value because it says it's okay to be equal to it. We want all the things that are greater. Now if you're unsure if that's really true, then pick a value from the number line that would be in this shaded area. For example, 0 is greater than negative 5, but negative 6 is not greater than negative 5. And when we plug in those values to check, negative 2 times 0, and we want to know, is that really less than or equal to 10? Well, here we have 0 is less than or equal to 10. 0 is smaller than 10, so that is true. It's true that this part of our solution should be included. So then let's also try that with negative 6, something that's supposed to not be included. Negative 2 times negative 6, and we want to know, is that less than or equal to 10? Well, negative times negative gives us a positive 12, and 12 is not less than 10. It's greater than 10, so this value is incorrect, and that shows us that we have the correct part of our graph shaded.